Good morning. I'm Amy Johnson from the Midwest Manufacturers Association office, also with CMMA. This meeting is scheduled to last 90 minutes. We ask that you place your virtual name tag on, renaming yourself with your profile name and your company name. If you need help with that, just shoot me a chat. This meeting is being recorded and will be available on the CMMA website under the Events tab and Webinar Recordings. And just as a reminder, all of our webinars, including keynotes, tours, and marketing series, are all recorded and available as well. So you can find all of that there. With that, I would like to turn the mic over to our CMMA Board President, Les Engel.
Well, good morning, everyone. Welcome to the November General Meeting. Hopefully your days off will be off to a good start, but let me start with some gratitude from CMMA to all of you who continue to support and engage our organization amid these challenging and changing times. And as a sidelight to the gratitude, I encourage everyone every day to try and start and end every day with at least 3 gratitudes for yourself for the day. And we sincerely appreciate your attendance at our virtual gatherings as well as we all adapt to deliver and receive information safely and responsibly and to cultivate our personal and professional relationships. So although our methods of interaction and business activity have evolved, just at your place of business, be sure that CMA continues not only to exist, but to thrive and to accomplish significant outcomes and that improve the organization. So thanks too for completing our surveys. I really encourage that. Your input matters as we work together to elevate CMA's ability to meet and exceed your expectations every day. So, and today we have a sponsor for today. I'd like to introduce our meeting sponsors, Donald Berg, and he is with called AFS, which is Applied Food Solutions Consulting. So with that, I'll turn the meeting over to Don and he can tell you about AFS.
Thank you, Les. Hopefully, I'll be able to get my slide up. There we go. Are you seeing the slide, Les?
Good, you're good.
All right. As Les mentioned, I'm Don Burge. I'm the owner and president of Applied Food Solutions. It's going to be quick this morning. As a sponsor, you got about 2 minutes. So I'm going to talk a little bit about what we do, give you a story. And I think questions, Amy, will probably wait till the end of the meeting. This is the model for the organization. It's all about improvement. The food science part is where the business started. That's not what this group's probably interested in. So talk a little bit about troubleshooting, training, and continuous improvement methods, but rather than go through a nice boring bullet list about all those things, I decided to tell a little story about a very important part of continuous improvement, and that's quality as a business strategy. To illustrate that, I'd like to talk about driving cars. Here was my family's car in 1973. Most of you probably never experienced this, but in 1973, you probably drove a car that was made by either General Motors, Ford, Chrysler, or American Motors. There were a few foreign cars. Most of those were German, like VW, so on and so forth. So here's a little bit about it. These cars were big, kind of like driving a boat. They got about 8 miles to the gallon, and they lasted about 60,000 miles. Let's say that again. Most of you didn't. I'm going to say nobody in here experienced this. Nobody was driving 47 years ago, right? These things lasted about 60,000 miles. You knew people that had one that lasted 100. That was unusual. Most of the time, the repairs got so expensive, 60, you went and got a new one. Well, in 1975, along came a thing called the oil and gas crisis. Gas goes from a reasonable 33.9 per gallon to 109.9, $1.10, the terrible price. All of a sudden, everything changed, and this is what it changed to. This is what came in. They were small, which meant originally they were never very good in the American market. So they get about 25 miles a gallon. So now that takes the triple the price of gas. Now you've got triple the mileage. But the part that that really changed the world for the United States was that these tanks lasted almost forever. People started buying them and they're going 100, 200,000 miles with just standard maintenance with no problem. The big change was that the Japanese had invested in quality as a business strategy. And once they got into the market, they changed it forever. In fact, almost put the American companies out of business. And I think the rest that you're well aware of, they're well entrenched. Thanks a lot. Enjoy the meeting. And also I should mention, by the way, another important part of this change was automation. And we'll talk a little bit more about that in a little while. I think people bring that up. Thank you.
Okay, thanks, Dawn. And so as we've been doing at these meetings, and we do it as best we can, is that we'll do introductions. I'll go through, I've got a list that's mostly correct is the best way I can put it. And I will call out a name, and if you can just correct your name probably, and tell us what company or group you're associated with. And so we'll get that started. And my list, the first one is Dick Owen.
Wow, first in line.
Uh-huh.
Thanks, Les. Dick Owen with fairchanceemployer.com. We provide a solution for organizations to be able to better evaluate folks with a criminal record and kind of protect themselves with the compliance they need for protection from any lawsuits or anything.
All right, Tim Zapoy.
Good morning, all. My name is Tim Zipoy. I'm a business services coordinator with Central Minnesota Jobs and Training Services. We're an organization that helps job seekers in career transition and also helps business and industry to find, train, and keep skilled employees. And I also have the fortune of serving as a CMMA board member and very glad that you're here today. Thank you, Les.
All right, thanks, Tim. Angie Brick.
Good morning, Angie Brick with Rotochopper. I am also a CMMA board member.
All right, and Ann Hawkinson.
Hi, I'm Ann Hawkinson from Avon Plastics. We recycle and manufacture plastic goods out of Painesville, Minnesota. Glad to be with today.
Well, thank you. And a couple of them are listed here as first names. So Brian.
Hi, I'm Brian Strike with Beckel Engineering out of Dassel, Minnesota. We're an automation engineering company.
Okay, thank you. And then there's someone with CRISP, CHRISB. I see they're on the screen, but okay. We'll try and come back. And we've got David Miller, and you'll hear more from him later too.
I am David Miller with Kensington Bank in St. Cloud, and I'm a commercial lender.
And Dean Kiffmeyer.
Good morning, everybody. I'm Dean Kiffmeyer with Central McGowan and a CMMA board member.
All right. And Douglas Cook.
Hello, everybody. I'm Doug Cook with Headwater Strategic Succession Consulting, and I help business owners increase the value of their business and build a transferable business. And I'm also chair of the CMMA Marketing Committee.
Great, thanks. Eric Reisinger.
Good morning, Eric Reisinger from Bremer Bank. I'm a commercial banker there.
All right, Jacqueline Bestowed. I guess I got that. Might have messed that up.
That's all right. Jacqueline Bistadu, CPA at LB Carlson. We're a public accounting firm.
Great, thanks. And we have one named Jaya or Yaya. It was just Y, they just listed as Jaya. I don't know if that's J. Abraham that's would fit. And moving on, Jeremy Johnson. We lost.
Morning, I'm Jeremy from Franson Bank, Commercial Advisory Banking.
Okay. Yeah, there's always that unmuting problem, figuring out what's going on. And Jeremy Sandin.
Morning, Jeremy Sandin with Legacy Building Solutions. We manufacture and install rigid I-beam frame buildings with fabric cladding.
All right. And we've got Kurt Saponiak.
Kurt Saponiak, Process Logic, formerly Diversified Machine. We do industrial automation and robotics. And a tip for the unmuting, if you just hold down your space bar, it temporarily unmutes you.
Helpful hints. I keep this up, I might be able to make this work. You know, I'm hopeful the virus will go away and these meetings will go away before I have to become a true expert. And then we've got Mark Mueller.
Hi, everybody. Mark Mueller from Airs and Airs. We're a design build general contractor. We work on industrial facilities as far as maintaining them and modifying them, remodeling them, those sort of things. We also build new buildings.
Okay, and then we've got Scott. I'm not sure. It just shows a first name. We don't know where Scott went to. All right, well then I'm supposed to check in with Amy here about, but I see we got Bruce Hegberg showed up. I caught him.
Morning, everybody. Bruce Hegberg with Right Soft. I wish I had a hat like Doug Cook has. And awesome hat, Doug. And Kurt, I've been on so many Zoom calls before and I didn't know about the space bar, so thank you for that tip. I'm also a CMMA board member on the program committee, and we're always looking for the next presentation. We're all dying to get back to live meetings. Don't know when that'll be, but if you have some ideas, thoughts, suggestions about some other presentations that we have today, and thanks to Pete Rogers and Central McGowan for taking this one, but keep them coming.
All right, yeah, that's a good point about Doug Cook's hat. Maybe if we have to have another virtual meeting, we should have a contest to see who can get the best hat. You know, that could be an upgrade. And all right,
I do have
any
some
others?
more here. I have some more here, Les, and I
Sure.
like the hat idea because we do wear a lot of hats in manufacturing.
Oh, she's really good at this.
All right, so how about Dave H?
Good morning, everybody. I'm David Henkel. I work with Bruce Hegberg at RightSoft. We kind of specialize in manufacturing technology. Thanks for inviting me today.
Dwayne B.
Good morning, Dwayne Bringelson with Park Industries. We manufacture CNC equipment for cutting stone and metal here in St. Cloud.
Jeff B.
Hey, good morning, everybody. I'm going to be off video most of the time chasing kids around. I'm Jeff Borling with Gray River Energy. We're the generation and transmission cooperative owned by East Central Energy and 27 other distribution cooperatives around the state. I'm part of the economic development team there, so helping out with business expansions and today.
Thank you. Jim G.
Hey, good morning, everybody. My name is Jim Gruber. I'm with Midwest Performance Group out of St. Cloud, and I am researching the possibility of acquiring or partnering with a manufacturer in the St. Cloud area.
Joe W.
Hey, good morning, everyone. Joe Wolf with the risk management consulting firm Marsh & McLennan. We do business insurance consulting, human resources consulting, and employee safety consulting for primarily small to mid-sized manufacturers.
Kevin Z.
Good morning, everyone. Kevin Zickert here with Energy Smart, and we provide energy efficiency consulting to Minnesota businesses.
Kurt H.
Hey, good morning, Kurt Hogeson. I'm with St. Cloud State University, a CMMA board member, and just wear a boring golf hat.
But it's a hat. Lauren A.
Hi, Lauren Altschuler with Transworld Business Advisors. I help people buy and sell businesses.
Thank you. I know that I missed a couple. I'm very sorry. If you didn't get to do your introduction, please feel free to do now.
I'm Barry Cornamone, Northwest Partners based in St. Cloud, specializing in employee benefits, property casualty insurance, and risk management. Thanks for having me this morning.
Any others that we might have missed? Jump right in. Don't be bashful.
Not bashful. So Rob Stark with Edward Jones in downtown Buffalo. I help use an established process to help people set and achieve their financial goals.
All right. Anyone else?
I might be last. Good morning, Joe Francis, Central
Hey,
McGowan.
good morning. Good to see you.
Tuning into our big keynote speaker this morning.
All right, glad you're here. So we think we got everybody, Amy? Because then we've got a couple of other business announcements. One, what we've been doing at these meetings is we also like anniversaries. So, and if all goes well, you're going to see a slide show up about this. Mostly, there we go. Things are looking up. So for a 5-year anniversary, the one we've got for this meeting is American Door Works. So I want to thank them for their continued membership. And then what's interesting, in the midst of all this virus and everything, we have continued to grow, and we actually have some new members to share. So we got the business owners, succession strategies, data marketing, and Edward Jones Financial, Hanson and Company Woodworks, the Headwaters Strategic Succession Consulting, and the Minnesota Wastewise Energy Smart. So I just want to thank all of those folks. There's some of them here I know at the meeting today. Just appreciate you being members and joining our group. And thanks for being involved. And the next thing we're going to introduce is Dave Miller, and he's part of our membership committee. In fact, he's in charge of our membership committee. And he's going to explain to you, we had a membership incentive program. So in the midst of all this, if you can find new members for CMMA, why, he's going to explain how there's a prize to be won.
Exactly. Thanks, Les. Again, David Miller, Kensington Bank, Chairperson of the Membership Committee. Just wanted to remind everybody about Riveters Club. It's a way to earn points or rivets. And as you hit certain milestones, you qualify for cash prizes. And wanted to let everybody know that even though our meetings this year have been virtual, you can still get points. Amy, Sandy, and I are still tracking that. For example, you can do like Lance Lewis Industries. He's unfortunately not here today. Lance has been adding points by persuading members to join, new members to join, despite not having the meetings in person and being able to network like we're all used to. He's been touting the organization, the things we do, our involvement with communities, the industry, with our schools, education, and everything. So again, just a reminder, please do not forget about inviting guests and talking about CMMA when you're out dealing with your customers, your vendors, etc. So again, please think of the Riveters Club and earning some cash.
All right. Thanks, Dave. And oh, and by the way, the check's on the way to Lance, I understand.
Yes, it is. Yep. We'll recognize Lance the next time he's able to join us.
So next thing up to what we've been doing for these meetings, we're going to do some breakout sessions, networking. And so then Amy will throw the switch and all of a sudden you'll be in a group of few people. And the first question is, what businesses are you aware of or you own that have utilized automation? You know, and if it was your business, how did this impact your employees? So we're ready to go, Amy?
Experience with the breakout rooms, and I thought that was excellent.
Great. That's what we hope. We don't do this to try to create stress. So is anything?
Oh, I have to talk to someone. Oh, no.
What was that? Somebody had an exciting moment there, huh? I don't know. Our group was pretty well split. Half went for the cabin and the other half went for the beach. But then there was some debate that maybe if this continues, we could figure out if our face-to-face meeting, we could do it on the beach somewhere. You know, might be a little travel involved, or else it's going to be a cold beach. So,
I
but
would
in
be
any
in
case,
favor of that, Les.
yeah, right. That's it. But there was other discussion I had about we might just send every participant a bag of sand and tell them to enjoy. You know, might be as good as it'll get. Okay, we're ready for the main speaker today. So I want to, and I should point out that, and sidelight, I forgot to mention earlier, for people who might be new, normally in December, we would have had a social and we wouldn't have what we call a regular meeting. Needless to say, the plan for the social self-destructed and the board decided to give it a go for this month to have a regular meeting, at least to keep everybody connected and visiting each other. So that's how this happened. If you've been an old time member, you normally wouldn't see a meeting in December, but I think so far it seems like it's gone very well. And so, and for our speaker today, I should also tell you, he'll explain, he will cover the tour as well. Since we normally, again, for new members, our meetings traditionally will have a speaker with a presentation on some topic, and then there will be a tour of a manufacturing facility where you would really go to their facility and see it inside. And needless, COVID has changed that plan too. So the speaker today, though, the company's involved in this is Central McGowan, and they're a third generation family owned diversified company. And they were founded in 1965 with the merger of McGowan Welding Supply of Little Falls and Central Welding Supply of St. Cloud. And it's grown to include three distinct businesses: the FANUC-authorized automation and robotics integration division, a leading industrial welding and medical gas and supply business, and a CO2 Solutions division that supplies beverage, carbonation, water treatment, and dry ice systems and products. So the company serves 20 plus industries with customers spanning most of Minnesota and the areas of North Dakota, South Dakota, Iowa, and Wisconsin, and automation implementations across the US and internationally. Central McGowan has 4 fully stocked retail stores in St. Cloud, Little Falls, Burnsville, and Fargo, more than 70 Minnesota dealers, and a CO2 distribution hubs and stores in St. Cloud and St. Paul. So speaking on behalf of Central McGowan today is Pete Rogers, the Vice President, General Manager of Automation. Pete joined Central McGowan in 2019 to focus on taking the company's growing automation division to the next level. So Pete possesses a strong mix of technical and leadership skills. Prior to Central McGowan, he spent nearly 13 years at ACETA, where he most recently was VP of Operations, responsible for overseeing ACETA's service, integration, controls, fabrication, machining, and assembly groups. Before that, he held positions of integration manager, production manager, welding segment manager, project manager, and robotics systems engineer. Sounds like you should be able to cover whatever you might need. I think that's good. So Pete has an Associate of Arts and Sciences degree from Central Lakes College in robotics and automated systems, and is FANUC Master Certified. For the past nearly 5 years, Pete has been a Generation Next Task Force volunteer for the Association of Advancing Automation, a healthy, growing organization created to maintain continuity and momentum in the A3 members organization as leaders begin to retire. So Pete's married, he has 2 children, enjoys car racing, drone photography, hunting, and fishing. So with that, we'll turn the meeting over to Pete.
Good morning. Let me get the right screen here. All right. Well, thank you for the introduction, and thank you for everybody taking the time today to sit down and learn a little bit more about automation and meet virtually here. I know it's not so much fun meeting virtually. I can tell you presenting, I think I like presenting virtually better than I do in person. So with that, we'll get started. This presentation is why automate. So it's not switching slides here. Here we go. So the agenda of this presentation, I want to cover 4 main topics: the current state of automation, the benefits of automation, what can be automated in your facility, and how to start calculating an ROI. So with this, we can get rolling into the current state of automation, and this is more of a global look at automation. So not just regionally, not just in the United States, but globally. So in 2019 was a good year for automation in North America. It was up just about 1.5% over 2018, and in the US alone, we installed 33,300 arms. This year, it's obviously been tough. Capital spending amongst the COVID has declined quite a bit. So through August, it was approaching 20% off as compared to 2019. But the big thing here to look at is how the US stacks up against other countries. So we installed 33,000 arms, and we're number 3 in the world. Japan was close to 50,000 arms, right? But China is 140,000 arms. And so it's quite a drastic difference there. China actually put more arms in than the next 5 on the list combined. So that's it's a little bit strange, but you kind of think back on why some of that is happening. 2.7 million robots currently around the world are working in factories. So that's a pretty good number. Can get a lot better. So if we look at how many robots were installed, the next thing I want to show you here is how does that stack up? There's an interesting stat here. So if you look at Singapore or even South Korea, they have close to 10% of their manufacturing workforce is robots. So what this chart shows is number of robots installed per 10,000 employees. So if you look at Singapore, they're at 918 robots per 10,000 employees. And if you look at this, the US has actually got a higher robot density in manufacturing than China does. China also has a lot of people and a lot of manufacturing, right? There was a lot of manufacturing moved over there for consumer items, and so there's a lot of factories, a lot of factory workers. They're looking to fix that. So it's kind of interesting when you look at robot density, how Singapore and South Korea are just so far in front of the rest of the world as far as robots in manufacturing. So essentially, what's going on in China is over the years here, since they've gotten so much manufacturing, their economy is growing, right? The quality of life's growing, and so is the cost of labor associated with that, right? And because of that, over the last 5 years or so, we've seen a lot of reshoring. And the reshoring is happening because automation is getting to a point where it's cheap enough now that if you automate in the US, you can very easily compete with the lower labor costs in China. Some of the downfalls with China and offshoring of manufacturing is you got to do large quantities, right? You got to fill a whole shipping container and get it shipped across the ocean. So you have a lot of inventory. You lose a lot of control of your process and your quality. And I think a lot of companies found out they lose control of their proprietary information. And so being able to automate in the US and win back some of this manufacturing work is really a trend we're seeing right now. So, but China's realizing that, wait a second, everybody else is automating. We're losing a lot of this manufacturing work. we need to start automating or we're going to be making nothing in the near future. And that is why they are buying robots as quick as they can be produced. For example, you saw that slide, there was 33,000 installed in the US. There was one company in China that actually had purchased 39,000 arms in one shot. So, I mean, the government is highly invested in this. Obviously, they're very, very tied into business in China with the way that's set up over there. And so they see this as the future of being able to keep the economy going and manufacturing going. And so they are automating as quickly as they can to help keep up with North America and Europe and others. But so we are somewhat in a race to automate and keep our systems efficient and flowing and retaining manufacturing work. So the next part I want to talk about here is the benefits of automation. We're going to go through a few different things here, but some of the benefits of automating in your facility consist of part consistency, right? So you take some of the human element out of it. We all have good days and bad days, and part quality can vary depending on good days and bad days. Automation can also help reduce a lot of rework with parts, right? Because of the consistency. And so rework can go down, scrapping of parts goes down, and there's quite a bit of cost associated with that in certain processes. So automating it and getting it very fine-tuned can really, really help you on the part consistency side. One of the biggest things, this year shook things up a little bit, but the problem is still there underlying is there's a huge labor shortage, right? Middle of 2019, I mean, there was the unemployment rate was low enough that basically nobody's looking for work anymore at that point. And so some of the biggest hindrances to a company growing or getting to the next level is the fact that they couldn't hire enough people to even produce what's needed to grow the company. And so filling in gaps in the labor shortage with automation is a big deal. You can put a robot in an area that's maybe really redundant, very easy, and you can utilize that employee in a different part of the facility. You're not actually replacing an employee, you're relocating an employee in your facility and putting them in an area where it's much more value added to your process. Safety is a big concern in most facilities, and obviously I think rules as years go by are going to get more and more and more stringent. You can put robots into places where it's dangerous, repetitive, ergonomics are horrible, heavy lifting, right? They have robots now that lift less than a pound all the way up to 5,000 pounds fully loaded. So kind of anywhere in between there, you can find a robot arm to handle parts. And so this can drastically increase the safety of your facility getting robots into certain areas. Some more benefits are increased throughput. It's kind of the tortoise and the hare, but if you envision even slowing your part process down just a little bit. So imagine it takes you a minute to weld a part. Even if the robot, for example, were to take a minute and a half or a minute and 45 seconds, but it runs part after part after part, no breaks, just keeps going. At the end of the day, you actually find that the robot's producing more parts. We all know that you probably produce a lot more in the morning when everybody's fresh doing things, but as the day drags on, people are, especially if it's rigorous work or that they'll wear out over time, and you slowly kind of your process slows down by the end of the day. That can be one of the benefits of automation. It completely runs the same pace nonstop. There's also abilities to be able to queue up large amounts of work, so that imagine all you do is run a 1 8-hour shift in your operation. You might be able to queue up 2, 3, 4, 5 hours of extra work for the robot system. And when you leave after your 8-hour shift, you shut the lights off. And when you come in the morning, you have all that extra work completed. Not all operations can be set up like that, but there's a lot that can. So you can extend how long you're actually producing parts per day. Optimizing part flow is another big area. So I think we could all probably sit back and think about how many times a part actually gets touched from the start of its production to the end of its production. And some of the touches are needed, some of them are not. So if you envision a process that you have a laser cutter and it's cutting out sheets of material, and so it cuts all these parts out and it gets set down, and an operator is sorting those parts afterwards onto a pallet, right? And then that pallet is picked up and moved, maybe even to another whole section of the plant, depending on the size of your facility, to be run through a press brake, right? And so then an operator picks the part up, bends all the parts, and more than likely sets them back down on a pallet to again be picked up and maybe brought to another completely different part of the facility where you're welding parts, right? And so it goes into that process, and all the parts been moved around the facility 2 or 3 times, and it's been handled at all 3 of those steps throughout the way. And then from the welding, you know, it could even go back onto pallets again into an area where it needs to get sorted, assembled, put in packages and whatnot. All along that entire time it takes you to pick up those parts on the pallet, move it to the next station, pick it from the pallet and put it into a fixture or onto a press brake, adds 0 quality or value to your part. All it really does is raises the cost. So with automation, there's ways of being able to kind of focus some of those larger areas and put them all into one system. So imagine what I like to call a focused factory on your floor, where you have a high enough volume that there's a laser cutter that flows right into a press tending system that flows right into a welding system, and from laser cutter to just before it's ready for maybe powder coat, nobody touched it, right? That's it. That can be a huge deal as far as removing labor costs and non-value added touches on your part. Not only that, it can reduce fork truck traffic on floors, right? Fork truck traffic is, it's by nature not all that safe, right? There's a lot of safety things that are done to keep people safe, but at the end of the day, it's like cars on a road, right? Eventually there's going to be some crashes or some stuff that happens, and whether it's humans that get hurt or equipment that gets damaged, reducing fork truck traffic can be a big benefit as well. Floor space savings. This one is very dependent on applications, but there are times that you can reduce your footprint on your factory floor by upwards of 50%. Just by automating it, right? As you're doing processes by hand, we need enough room. We need to be able to move around. We need to be able to handle parts safely with jib cranes and different things that all requires space. So if you can really narrow this process down and put the robot in as small of box as possible, that can add a lot of floor space. And most of us know floor space is a pretty valuable commodity in most instances. So moving on from some of the high level benefits of automation, I'm going to give you a high level now of what can be automated on your factory floor. There's a myriad of different processes. So starting off with their assembly processes. So taking small parts and putting them together, right? Part after part after part after part. These systems can be more high end. They're more expensive because there's a lot of dexterity that goes into these systems, but they also can be very valuable because what comes with a lot of these assembly systems is in-process quality, right? So you can use vision systems or other type of sensors to not allow you to assemble something incorrectly, right? Again, as you or I assemble something, there's a chance that we could do something wrong. And automating some of those processes takes some of that quality control or quality assurance and puts it right into the process. So there's a myriad of different things you can do in that world. Floating next into welding, Plasma cutting. This is a big one that's out there. Welding's been a very, very established automation application type for many, many years around the country. This is being used heavily in the auto industry. I know we talked about that a little bit earlier, but welding is a big one that can really, really improve weld quality, right? Welding is very dependent on the operator having a good day and paying attention and making sure they're putting down a good weld. The robot, once programmed and brought in, parts can be brought in, they can be heavy, it can be spun, turned, flipped, moved into position very easily, which in a lot of times can reduce how much time it takes to create a part. So if you imagine you have a large part that needs to be rolled over 5 times and you need a welder to use a jib crane and a hoist to flip this thing over, in an automated system, you can literally set that part down and spin it with a programmable servo motor that the robot controls. And so they always ensure that your weld is in the correct position, but also a very, very consistent weld quality. The interesting thing about robotic welders versus your hand welder, and they're bringing some of this into the hand welding and it's being utilized, is the robotic welder is a closed loop system. So if you're telling the welder, I want 25 volts coming out of this gun during this entire weld, if it senses it's either going down or going up too much, it'll automatically adjust on the fly. So what it's really doing is putting as consistent heat input into that weld as possible. Plasma cutting can be automated as well. There's a lot of benefits to that. So you can automate flat sheet plasma cutting, as well as beam and tube and pipe and all kinds of different things there. So one of the new things that's come into the market, and I'm sure you've all kind of heard the term, the collaborative robot or cobot. These robots are unique. The one I'm showing here is actually a welding application, but you can use it for a lot of different applications outside of that. The cobot itself is a robot that you can work next to. So you're going to see in some of these slides, these robots move very quickly, handle very high payloads. So there's a lot of safety involved around them, right? They're fenced in, so you can't accidentally walk in front of it. Cobots you can work next to. They are set up, they have high-end sensors in the arms that if it bumps into you, it stops, and they don't exert a lot of force. Cobots are a little bit slower as far as top speed, because once you get too fast, that bump isn't so much of a bump anymore. So this is a big thing that's coming into the industry, being able to do very simple welds. The cool thing about these cobots versus the standard industrial robot is you can grab this robot with your hand, move it into position, teach the start point of a weld, move it to the next position by hand to teach the end point, and then hit start, and that robot will play back exactly what you just did by hand. So it's very, very easy to program and can be used in more of the job shop environment, which has always been the tougher spot to automate, right? Automation, you always think high volume, high speed, very low part number mix. These collaborative robots that are hitting the industry now are kind of breaking into the high part mix, low volume world, which allows a lot of people that historically haven't been able to automate things in the past to be able to utilize automation. So you imagine this robot, you have an operator runs over there, you put a part on there, you teach a weld, and maybe you only weld 50 of them, but it may have taken him 10 minutes to program the weld, where on a industrial system, it can take much more time than that. So after that, you can, after that batch is done, you can put another part on there, program it very quickly, and you're off and running again, and not having to add a whole bunch of welders to your mix to do it. So pretty cool new technology hitting the market. The next one on here is palletizing. So end of line palletizing. You envision a box running down to the end of the line and an operator picking it up and stacking pallets all day long. I'm sure There's a lot of it out there, and I'm sure some of you are familiar with it. This is a very good area to automate. Not only does it save safety ergonomically from lifting boxes all day long, but the cool thing is you can put multiple zones on this. So for example, the system you're looking at here actually has 6 different pallet locations. They'll run up to 5 different part numbers at a time on the same inbound. And it's as simple as a barcode scanner. Reads the barcode on the box and the robot knows which stack it needs to go on. The other neat thing about this system here is phase 2 of this is actually to stack these boxes on a pallet, but raised up in the air about 4 feet. And what's going to happen in the future is an automated guided vehicle. So an AGV, so a robot forklift, essentially, is going to come over once the pallet is full, pick it up and bring it to the next area and set down an empty pallet. So this is automating these little pieces, helps link processes together and makes everything more consistent so that maybe you can bring in automated fork truck traffic into your facility. Material handling, this is a big one, and machine tending. So you envision all the CNC machines out there in machine shops where you have operators lifting parts off of pallets, loading a machine, hitting the start button, right? This is a process that can be automated fairly easily, replacing the operator with a robot. The biggest bang for your buck on these is the heavier the parts get. So there's a lot of machine tools out there that are loaded with a jib crane or some sort of hoisting device because parts are too heavy. The robot can easily swing over to a pallet, use vision to find the part, pick the part up and load the machine. And they are completely Ethernet connected now to most of the new machine tools. And so the machine and the robot are talking, and once loaded, it can tell the machine start. And the machine can run through its process, open its door and tell the robot, I'm done, come pick it up, and continue that process. So this example here on the screen, they're actually picking a part up, loading a laser marker, and then putting it on an outbound conveyor. So the small part that's on the screen here used to be on a pallet, picked up by an operator, set in this door you can see through here, and hit start, and then picked up and placed back on a pallet. What they did is they actually tied these conveyors that you see going in and out of this system to the process that's upstream from this and downstream. So now the process that it comes from, which is some machining and assembly, flows down the one conveyor, it gets marked, and then it flows back out to go into the next assembly process. So very streamlined again. Material removal processes. So, and what material removal processes are is polishing, grinding, deburring, maybe some cutting. And so this system here actually used a router to cut some aluminum panels for this company. And these processes can be automated. There's a lot of homework and a lot of work that goes into a material removal process. Mainly because if you think of welding, there's a pretty strong accepted spec in the welding world that a 1/4 inch fillet needs to be fall within this spec. When you get into the material removal process and when you're deburring, a lot of times there's no set spec that says it needs to be X, Y, and Z that's kind of accepted by everybody in manufacturing. And so there can be a lot of testing and that is involved with this, and also trying to figure out what kind of media is correct, maybe for cutting, polishing, or grinding. These processes can be hugely beneficial, but they do take a little bit longer and tend to be on the more expensive side, but can have a huge return in the end if the right steps are gone through. So I spoke a little bit about return. I want to give you guys some things to think about as far as where do you start? How do you calculate an ROI? What are the things I should look at? Obviously, some of the easiest things and some of the things that come to come to the forefront of everybody's minds is what kind of labor savings on this process, right? So you're going to want to calculate labor savings. A lot of these robots can run unattended for long periods of time. And so what you need to figure out is how, if I'm taking a welder away from this process and putting them into a more advanced weld that's tougher for a robot to do, and I'm using an operator to just make sure that this machine is being run and being attended to and continues to have work to do. What labor savings are involved with that? Is there a lower cost to the operator versus the welder? And in a lot of instances there is. So that really helps out. How much time is that operator spending at that one system during a shift, right? Do we have the automation set up where the operator might be able to tend 2 or 3 systems throughout the day, depending on how long the system can run unattended? So you're going to really want to dive into some direct labor costs. Productivity gains. And so this is a big one. We talked about it a little bit earlier with some of the benefits is your increased throughput. What are we looking at? And depending on what your forecast is in sales and what you're doing there, what you don't want to do is buy a robot system that only does what you're doing today. If you're planning to grow, you want to look at this and say, I want a system that's able to handle 30% more, 25% more than we're doing today, so that you give yourself some room to grow without the added investment right away. So you're going to want to look at how much more productivity are you getting out of this system versus doing it manually, right? This can be a myriad of different things, right? It can be labor costs. It can be the cost at the times that the plant is open and running. So increased productivity can also come from what I spoke about a little earlier is, does this process have the ability to run 3 hours after everybody goes home, right? And so those are things that you're going to want to look into. And now you're maybe doing 11 hours of work for the cost of 8 hours of labor, right? So these are the things you're going to want to document. Safety costs. This one can be a little tougher, but if you're not having a welder standing right there, do you have the cost of a weld hood and weld gloves and weld coats and all of that kind of stuff that was directly related to this part before? Is that being eliminated? Is this process ergonomically not great and you've had workman comp issues associated with it, right? Those costs can be put into your ROI as well. Scrap costs. This one is tracked very well and very poorly in different facilities, right? Some people are tracking, or some manufacturers are tracking right down to the last penny on what's scrap and rework costing our facility. And some really aren't doing much with it. This would be one that I would really encourage people to look deep into if you're thinking about automation, is try to get to some of those costs. How much are we actually scrapping? How much time are we actually spending reworking it during our current process? That stuff's expensive. That's, at times you could be putting double the labor into one part just to get it through because something got screwed up and it needs to be reworked. So I would encourage everybody to look into some of those areas because there can be bigger dollars in there than you think. Not everybody deals with this, but some people do. Manufacturers have to deal with their customer rejecting parts because of quality, right? And if you could increase your quality by 30%, meaning you're reducing your customer reject cost by 30%, what is that number? And can you sustain that over time? So these are all items that you're really going to want to look for and put down on paper so that you can decide, does this system make sense for me? There's a bunch of different calculators out there. I'm showing an example of one on the screen of a $225,000 system. Currently, their production runs 2 shifts a day, 5 days a week for 50 weeks a year, right? There's some small electrical costs per hour for the robot and an annual labor cost fully burdened of a welder, let's say, is $60,000 a year. That's probably a pretty conservative number. It's probably tough to get to that in the weld world today. But if you can set up a process that removes 75% of that individual's labor and gets you an extra 25% of throughput and a random $1,000 of extra savings per year for scrap, rework, and ergonomics, that number is probably pretty conservative as well. This system right here, based on those couple metrics, has a 2-year return on investment. And that's huge, because I know there's a lot of us in this room that if we could give a financial guy $100,000 and he said in 2 years, you'll still have what you gave me, and also returned another $100,000 in 2 years, we probably wouldn't be on this webinar today, because we'd just be doing that instead of working. So, I mean, these are huge returns, and these systems can run, depending on what they're doing, anywhere from 10 to 15 years. In my past life, I've had a system that was 28 years old, still running. And so again, it was kind of funny that we segued from the Japanese automaker. A lot of these robots are Japanese made, and they're very high quality on the mechanical side. So with that, I'll open the floor to any questions.
All right. And as a reminder, the questions can be submitted through chat, and you can do that either publicly or privately to myself. I'm happy to relay those to Pete for you. Pete, we do have a question here to get started with. Do the systems need regular maintenance?
Yeah, that's a good question. Well, with anything mechanical, of course, that's moving around and doing things, there's going to be maintenance involved. These robot systems, like I actually just mentioned, are made to run and made to run hard. And so what we suggest, and what a lot of others do, is the robots actually have grease that lubricates the joints where the gearboxes are. We recommend going through and cleaning that out once a year, pumping grease through once a year, depending on the operation. It can go longer than that. You can push it to every 18 months or every 2 years. What we found over time is it's very hard for everybody to track. Am I on an 18-month cycle? Am I on a 2-year cycle? When was it last greased? So for the low cost of actually being able to go in there and ensure that your robot's not going to get damaged because it's got old grease, we just say set a reminder once a year, have us come in or somebody else come in and get it maintained. Beyond that, there's going to be some small wear items, obviously welding. If you're familiar with that, you've got tips and liners and different things that are consumables on those robots as they exist. So there is some maintenance, but it is very low end. And then that ROI, I didn't really mention that in there, but I had I think $1,500 or $1,000 a year budgeted in there, and that system still had the 2-year return. So.
Great, thank you. And we do have some great questions coming into chat here. How many robots do you have in central Minnesota?
Well, that's a good question. There's probably 400 or more out there currently today. So.
Next question. Does OSHA or other agencies have any programs to help fund robotics projects to reduce injuries, etc.?
You know, so that's a good question. I know we've got an insurance guy on the phone here, and I've often thought about how we could start tying some of these safer operations with robots back into savings for customers. I am unaware of any at the moment. OSHA, as far as safety goes for these systems, actually uses the RIA, which is Robotics Industry Association, that has a set of ANSI safety policies that everybody follows for these systems. But I haven't heard any yet programs like that as far as for making your facility safer.
Thank you. So I guess back to the central Minnesota questions about how many robots there are, how many are welding versus otherwise?
Boy, I got to be completely honest with you. I am not sure off the top of my head. That is an answer I can get for everybody though.
All right, thanks. Will we need to hire a robot expert?
That's a good question, right? So jumping into robotics or going into it for the first time, there's a pretty big intimidation factor, right? It's a robot. Holy cows, how the heck am I going to run this thing and how is this going to work? And the answer is right out of the gate, no, you don't need to hire a specific robot expert. Some of the best things we've seen customers do is kind of pick a champion, right? Do you have somebody in your facility or in that area that is super interested in learning how this robot works and do that? And there's a lot of training out there available. And then there's also the support of whoever might be building your system, right? Whether it's Central McGowan or other companies out there, they have the ability to help you through that. Most have 24-hour phone support. You can call and they'll help troubleshoot over the phone, and a myriad of different things they can go through. But right out of the gate, no, you're not going to need a robot expert, but we find there's a lot more success if a company can kind of pick a champion and really make them the owner of this thing running well when it gets to your facility, right? They'll have a lot of ownership. And I've also seen some companies even say, hey, we're going to give you a little bit of a spiff off of this thing. So the more parts that this produces and the better you can make this thing run, you get a little bit of money for that, right? So give them reason to make it run as fast as possible and do as much production with as little downtime. So there's some neat different things you can do with your internal employees. The coolest thing about this is it gives you the opportunity to create maybe a position that hasn't been there before and take one of your own employees and grow it into that with proper training and some different things that now all of a sudden you have a much more invested employee and you're learning, and they can help train and bring the education level on the robotics side up internally as well. So
thank you. Next question is, are there training options available?
Yeah, so I touched on that a little bit, but there is a ton of different training stuff. A lot of these robot companies do it themselves. So if you're purchasing from an integrator like Central McGowan and it's a turnkey system, it'll come with a certain amount of training, right? We'll get you started. We're making sure that you can operate it. But there's also the ability to go to companies like Lincoln Electric has training. You can go out to their facility and they'll give you a more in-depth weld training based on what you're looking for. FANUC themselves, which happens to be the robot manufacturer that we use, they have an amazing training facility with classes going every week that you can sign up for, whether it's mechanical maintenance, programming, software training, or electrical training. So they've got it broken down very well. And now because of the pandemic, and we're all sitting here on a webinar, there's been a big shift to getting these educational tools on the web, able to log in, watch videos, and do different stuff like that for different lessons. So it's getting easier and easier to find training. It is an investment though that can be very important, not only picking the right leader in your facility to be the champion of this system, making sure you're investing in the proper training so that it goes smoothly as possible. That training investment returns dividends usually. So.
Thank you. I have one more question here in chat. If you have any questions in the audience, feel free to submit them now. What are the first steps to take to decide if automation is right for us?
That one, there's a bunch of different things you can do, but really kind of looking at that ROI piece is take the time and do a good study of an area. Make sure you understand all the costs associated with the part flowing through there. Gathering rework data if you're not tracking that closely, gathering scrap data if you're not tracking that closely. Really doing an assessment on what is the cost of safety in that area. It's gathering a lot of information. So beyond doing some of that internal homework, there's obviously reaching out to companies that can build these systems, can help guide you as well, right? There's sales staffs that can come in and say, okay, here's the areas you should look at. Here's the things you should pull. You got to understand though that with automation and what it takes to do it, albeit there's a lot of it out there, there's still a lot of things that go into a custom system and into your particular process, right? You might be doing a process of welding a similar part as somebody else out there, but I guarantee you that process isn't exactly the same. And so any automation company is going to come in with a large list of questions to make sure that what is being looked at and the steps going through to getting the right systems selected and the right components in there, that all the information is gathered so that at the end of the day, when we start building this thing, it actually meets the expectations, right? You envision how many different part numbers there are, what are their sizes. The interesting thing about automation is you quickly learn how advanced humans are. And when you start trying to replicate our activity and our brain and our dexterity with a machine, right? We can pick up just about any part that's light enough that we can hold, right? If we have 10 different parts sitting in front of us, it's no problem for you and I to grab it with our hands, pick it up, flip it around, move it. With a robot system, you may literally need 10 different grippers and the engineering associated with it because the parts are different enough that they need to be held differently so that they can be held repeatably. So there's a lot of information that's gathering. The biggest thing I would suggest though is some of the biggest hurdles to getting automated, right, is the financial investment, right? It's an investment for a company. And so you want to do your due diligence on the financial side to make sure that this system is going to get you the appropriate return. There's a lot of integrators out there that can go down the path and build the most advanced factory in the world. You might not have a return on that, right? And so being able to know those numbers and know where the limit is and be able to tell yourself, you know, this section here has a return. If we add all of this on there, actually, you know, financially that doesn't do anything for us. And so that's where you can work with the builder and the integrator to make sure that you're getting the biggest bang for your buck, getting your production done, but also doing it with a decent return, right?
Great. Well, thank you, Pete, very much. That's all that I have for questions in chat, but I do want to remind everybody that if you wanted to talk to Pete or network afterwards, we will be hanging out to be the last ones on the call. So with that, I think I will turn it back over to Les.
Well, Pete, I do have a question. I don't know if you touched on that, is the effect on workforce. I mean, the first story you hear from the workers is on being replaced.
Yeah, that's good.
Robots. And I think you have any information about what is that impact overall for the company?
Yeah, so that is a great question, and that's a point I didn't touch on, but yeah, so press around robots, right? You hear the news, you hear different states saying, you know, robots are taking everybody's job, right? It's an easy one to see because they're being put into places replacing specifically what people on the factory floor might be doing. There's a lot of studies out there that are actually showing the more automation a company has, the more employees grow in the company, because what it's allowing them to do is bring on more work, and in turn they need to hire more people. Now, are we directly replacing some of the duties that employees are doing? Absolutely. But you know what, a lot of those duties are not duties that a ton of people want to do day in and day out. And to be honest with you, with the newer generations of knowing there's a lot of paths to go, there's a lot of education paths to take, it's going to get harder and harder to find individuals to do those jobs. There's just a lot of options out there, right? The millennials are kind of the start of it, but Gen Z, I can guarantee you there's a lot of Gen Z individuals out there that are going to struggle to do a lot of factory floor work, right? They've lived in an entire life of smartphones and the internet. You know, they can work from home before they're going to do that. But beyond that, as far as how that goes, you also want a good communication plan. So say this is your first robot, right? Your employees are naturally going to be nervous about, oh my God, are they going to put this in? Am I going to have a job next week? Right? So what you're going to want to do is formulate a good communication to the individuals and explain to them why you're doing it, what the benefits are, and what maybe now the future opportunities are for these employees. Listen, you're not going to have to do this anymore. What we do want you to do, though, is go to training and be able to learn how to run this. And a lot of times what's going to come with that is better wages, better quality of life. And I've had many examples where I put one in, and you go into some factories back when I was programming and installing, it can be scary. I mean, the employees are not thrilled to see you there. And they're not always willing to be helpful because it's like, geez, this guy's coming in here to ruin my life, right? I've also gone back into those same factories 6 months later and had the same people going, oh my God, I can't believe I used to do that every day, all day. This is the best thing we ever put in here, you know, because all of a sudden they're like, I am not worn out at the end of the day anymore. I can go home and do some more because my back and shoulders don't hurt, or, you know, whatever it may be. So we try, and for as, you know, I mean, it's 15 years or so that I've been in this. I can't think of one off the top of my head where we put in a robot system and it was just like, well, these 5 employees don't have a job anymore. All right, the labor shortage is still out there. So if you've got the employees and you can shift them into a different area, you're going to do that. So
that's great. So it's really not as scary as some employees might think.
No, but there's still going to be that. So having a good leadership communication to your employees of why you're going to do this and why this is going to make your business stronger and what this means for them, the individuals in the future, is a good thing to work on as well when you're going to bring automation in.
Great. So any last minute questions? We're getting close to about wrapping up here. So if we don't hear anybody jump in, but I'd like to thank Pete for taking the time to share his automation expertise with us today and giving a glimpse of Central McGowan. And I think now you've got a little more.
I do. I have a couple slides of just some examples of some automation. So a little virtual tour.
And I'd like to thank the audience for being here, because what will happen is that we'll give this back to Pete, and he's got a little more of the tour of what goes on at Central McGowan. And then at the end, that Pete will stay on here, and I will be on here too. I think Amy stays on to the last minute since she controls us. But if you have any other questions I'd like to visit with Pete, why, if you just stay on and don't leave the meeting right away, why, we'll still be here at the end. So if Pete wants to go ahead and a little more glimpse of what's going on at Central McGowan.
Yeah, so guys, these are systems that Central McGowan has done in the past. And so I'm just going to talk through a couple of the different things that they're doing. So it's some of these what can be automated, but in more real life. So I'm going to give kind of a high level description of what's going on in the system and just let you guys kind of see them running. I gotta click back up here. So is it good to start? There we go. So one of the benefits of automation as well, and when I was talking about part consistency and in some of the assembly processes, being able to take some of the quality control and bring that in process. This system here is literally a robot picking up a part, setting it into a small CMM and getting measurements on it. And so what's happening is you'll see 2 locations where the part can set. This actually is getting smashed in between a process. So a robot's actually loading the one station and then another robot's unloading the other station, right? So this robot's job is literally to pick this part up and put it in a gauge and measure it. Some of the cool things that happen with a system like this, especially in machine tending. So you imagine you machine 700 parts and then you gauge a couple of them and you find out, oh crap, 200 of those parts, I had a bad tool in there, they're all scrap, right? This allows you to allows you to measure every single one, but now say you did find a scrap one, you can shut that machine and that process down immediately, right? So you might end up with 2 bad parts or however many are in queue instead of 200 at the end of the day. So this is a big thing with the costs of some of this inspection equipment, CMMs and stuff coming down, that's actually allowing you to 100% QC check all machined parts and be able to really have control over scrap, right? And so that instead of scrapping a large batch or finding out that half that shift that day, we were doing something wrong in that machine, it allows you to kind of narrow that down to every single part and really controlling those costs. We've had some processes that I've seen in the past in machining that was some really high-end machining, very delicate, that their scrap rate paid for an inline QCing of it. If they could eliminate, 80% of their scrap by doing this, it more than paid for a robot to be double checking the part measurements right in process. So that's a very cool concept. It brings you closer to that lean manufacturing or single part flow. Next video here is an example of something I spoke about earlier, is plasma cutting with a robot, right? So feeding a tube in and having the robot program to perform the cutting over and over and over again. Very cool, very easy to program, but again, the biggest thing is just going to be the consistency with this. You're going to get the same cut every time, even better cut than relying on an operator to do this by hand or doing it some other way. So a lot of different possibilities with this too, with square tubing, round tubes, I-beams, anything steel that you can get in there, I guess, or metal you can get in there to start cutting. You can put a plasma cutter very easily on the end of a robot and allow it to do the cutting. The cool thing is nowadays, with everything being shifting towards the 3D CAD world, right? There's still a lot of drawings out there that are 2D. There's a lot of people moving into the 3D world. There's a lot of offline programming software, right? So historically, you need to teach the robot to run this path that you're seeing this robot run. There's softwares out there now that you can load all of this in there virtually, given a 3D model of everything. It has exactly how the robot runs and how it does that. You calibrate the real system to the offline system, and from that point on, you could load in the 3D CAD of that part it just cut and tell it, I want you to program this part. And so the software will program it for you. You bring that file out to the robot, load it in, do a couple test cuts, and you're cutting it. And so instead of shutting production down to stand there with the robot and teach new parts or add parts to a system, you're able to do that from a desk while the robot's running production, right? If the robot's not running production, you're not making any money on it. So to be able to program something offline and have the robot shut down for 10 minutes instead of a half a day, that's huge. So here's an example of an assembly process. So this process is taking an O-ring and assembling it onto a part here. So it's dispensing some rings out. A gantry style robot's picking it up, putting it down. This one also shows an example of vision on the end of a robot, right? That's another thing, another layer. It's like, geez, if I historically, without vision on a robot, if you don't set that part in the exact same spot for it to pick it up, it's only going to the spot you told it, right? So now the advances in vision, whether it be 2D vision, 3D vision, allow you to be a little less rigid in areas. The robot find the part, maybe there's clocking needed on the part, right? So there's a notch on one side or a keyway that goes through a part like this, for example, that when you're assembling, it needs to be set right to that keyway or is relative to the keyway. The robot can find that, right? We don't have to find a fancy way of making sure that that part is rotated properly each time. So this is a very cool example of that, doing some assembly work that we talked about earlier. This is just a fun one to watch, but what these are is ceiling tiles, right? So you imagine the ceiling tiles you got in an office or whatever, but this is a cool example of a robot doing cutting in process. The coolest thing about this is the part never stops moving. So there's options now with what's called line tracking, and you can put a robotic encoder, which gives feedback of speed and position to the robot. It's the same thing they use on their motors on the robot itself, but you can mount that to a conveyor or to a press brake or to a myriad of different things, and the robot knows the exact speed that now this part is running and can do its process while the part is moving. And so this robot, and it's tough to tell in this video, but it makes a perfectly square cut to this even while the part's moving. And so the cool thing is you don't have to stop, make a square cut, start again, stop. This thing just does it really on the fly. So there's a lot of things out there now that allow increased throughput in robot systems because you can keep the part moving. For example, that first assembly system I showed in the what can be automated section of my presentation, those parts were actually all being placed onto fixtures, and there's 4 fixtures on 13 different rungs on a conveyor, and it never stopped moving. And those robots just kept assembling the pieces as they were moving down. They got crimped together and dropped in a basket, but they never stopped. They were always moving. So some really cool options there as well. Got one more video for you guys here. These videos get pretty limited out of our automation group because there's a lot you can show, or some you can show, and a lot that customers ask you not to. So this one here is actually depalletizing. So we talked a little bit about palletizing in the presentation where we're stacking boxes. This is actually taking a pallet that's come into a customer with a whole bunch of wood stacked on top of it, and it's depalletizing the wood and putting it into a cartridge that is then feeding a machine that builds pallets, right? So those are slats for a pallet. And so what this allows you to do is feed an assembly machine with a robot without having to have somebody stand there and take wood planks off of a large pallet all day long. So that is what I have for the virtual tour. Like they mentioned, I'll stay online here. So if there's any additional questions, I will take them.
All right. Thanks again, Pete. And thanks to everybody that joined us today. Should be another meeting. Suspect it may well be virtual in January yet, but we will have a meeting. So, and anybody like to say has any other questions, just hang on here as we leave the meeting. Take care. Have a great day.